Hello, welcome to Maths 4. So, wow, for some reason it always changes the colour, I don't know why. Alright, so Maths 4. So what this is going to be is going to be a recap of the preceding three in a similar way that I do the other educational series. So, the first thing I want to talk about is we can have sets of objects. So if we have, say, base 10 digits, right? You know, like this. And yeah, so what we could have is so this is a set with 10 objects in it, right? 0 through 9. Then we could have, say, that um, yeah, we could say, for instance, positive even numbers under 12. So we could also put less than 12 there. So what that would be, this would be a subset of it. So we'd have positive even numbers under 12. So we're going to have 2, 4, 6, 8. Actually, we should probably do under 10. So we can have 2, 4, 6, 8. And then we could then further say that something like, 2 and 6 is a subset of that. So that's one way to look at it. What else can we do? Got the natural numbers. Generally do it a bit like this. Do the sort of thing there. These all have this. So that's so basically, the numbers from 1 to n. P is prime. If p is greater than 1. And divisible by only 1 and p. Okay, so next thing we spoke about, we have fundamental theorem of arithmetic. All right. So this theorem, I'm not going to write it all out. It's going to be that every natural number can be factored uniquely into a product of prime powers. So for any number, all we could do is you can just do it like this. You just say you got 48. You just say, well, 2 into 48 is 24. 2 into 24, 12. Six, 3, and then yeah. So what's that going to be? So we can see that works out. 16 times 3 is 48. And you could do that for anything. So there's going to be these unique powers. Nothing else is going to amount to that. And they're always going to be prime factors. Yeah. So there's that. Well, obviously prime numbers don't actually count there. Then we've got integers. And here we have z again in this. I think there's a special word for how it's supposed to do this. It's something like embossed, perhaps. So integers, we've got, as you can imagine, minus 2 minus 1. No, oh, that's a 1. Yeah, and it's always a good idea just to put the same amount on either side in those situations. Okay, so it's just integers. Integers, yeah. And well, I think I actually might run out of room this time. But oh well. Integers is that. And we've got rational numbers, which are q here. So this is defined by p over q. P and q are integers. Okay, so it's any sort of rational number here. So yeah. Whatever it might be, right? Can have top heavy fractions, no problem. Fractions, basically. Next up. So we can say basically this. I'm not going to do it in the... this is basically how it is. And so natural numbers, positive numbers, integers, all numbers, q, fractions, and yeah. And also I may as well hit at this point put real numbers. And this is actually much smaller. This is like, you know, this well you might say this is much smaller. This is just massive. This bit here. Okay. So yeah. Okay. So yeah, I'm not sure how much got cut off. Probably a lot. Basically, what I was saying, we've got natural numbers here, integers, rational numbers, and then the real numbers also outside. This real number section here is much larger as well, because there's a lot of real numbers that do not fall into any of these categories, mainly irrational numbers basically. And yeah, so the rational, so the real numbers, which are defined by is basically just rational plus irrational. That's what it is. So yeah. So there'd be lots, roots in that, and pi, and transcendental numbers and all this stuff. But I'm not going to go into that though. And I also point out division by 0 is undefined. Purely because if we do basically 0x is 0, right? X times 1 over x for any number, so that would be like 1 times 1 is going to be 1. But in general, any number, that's going to be that. So yeah. So if x is 0, that's going to be 0 times 0 is 0. If x is 0, it's going to be 0 times 1 is 0, which would have to be 1. But obviously, it doesn't make any sense. So no. All right. Okay. Okay, so if we've got A over B and we times by C over D, we're going to get AC over BD. So yeah. So there's that basically. So there's no really, I don't know, so we'll just try, let's do 1 over 1 times 2 over 2. So it's just 1 times 2, but you can see 1 times 2 is 2, 1 times 2 is 2. So it's 1 times 1. Alright, it's basically 1 though, isn't it? And the whole point, right, is if you multiply the numerator and the denominator by the same number, it's always going to get an equivalent state. It's always going to be the same thing. You know, like 1/2 times 5/5 is going to be 5/10. So it's always going to be the same. But yeah, but that's just how fractions are multiplied. So well, it's not those terms. No, I'm pretty sure show someone like that. I think that's right. Yeah. So yeah, that's what that would be anyway. I almost feel like I have to. So let's just put it in those terms just for the sake of it. 320. Obviously, I wouldn't do it quite like this. All right. So the next one is A over B divided by C over D. That's equal to A over B times D over C. Okay, and it's because of the division here. Because when you have division, you would if you did like if you did a half divided by a quarter, you'd actually change that around. You'd flip it, so it'd actually be the same as that. So that's basically why you flip it. Because realistically, yeah, these two things are the same. It's just better to put it like this. This method is a bit, yeah. So basically, that's all you do. You just flip it around, and you get it's AD over BC. So again, we're taking this and this, and multiplying them, and then putting them both, putting over the denominator of this top fraction and the numerator of the bottom fraction. It's like a cross multiplying thing. For this one it would be, you can see it's going to be AD, which is 1. So AD 1/4, 1/4, and then BC is 2 times 1. Whichever way you do it doesn't really make much difference. Okay. And the next one is A over B plus or minus C over D. Same as saying A over B times D over D. So minus C over D times B over B. So yeah, so this one is like well, you have to cross multiply what do you do? You cross multiply these two, don't you? Then you cross multiply these two. Okay. And you've got this D here, and this D here, and this B here, and this B here. So it's like you got two of them, right? But yeah, we've already said, right? Yeah, I mean, if we just do d over d, yeah, because it works out to that. So there's the BD and there's the BD. Yeah, adding fractions is kind of funny, isn't it? Because even though I sort of, no, I mean that's the thing. It makes either way it makes sense because you just know that you just multiply the bottom. But I don't know. All right, I'm not going to dwell on that too much. Irrational numbers, square root 2, obviously can be plus or minus. Real numbers I've spoken about already. And yeah, I suppose I spoke about most things. If A is greater than B, if A minus B is positive, A equals B if A minus B is not less than B. Okay, and so there's, yeah, and you can obviously have different ranges. So X can be greater than 1. Yeah, so X is less than 4 but greater than 1. If you just put less than or equal to 4. Yeah, I mean, you wouldn't necessarily do things. So this is the opposite way to the way I actually did it, but anyway, it doesn't matter. So you could just have 1 here. So we know it's greater than 1. But we also know it's less than or equal to 4. So we exclude this point. Let me include this point. And yeah, that's all I've really done in the first 3 episodes. I'm going to be talking more about this stuff in the future. Until I do, though,